Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact straight from the leaders making it happen. Today, we're focused on metric engineering, the pragmatic bridge between board-level KPIs and the model-level objectives your teams actually optimize for. Why this matters now: organizations pour effort into better models, but the connection to revenue, retention, or efficiency is often weak or noisy. When measurement is unclear, investment choices become guesses. This episode walks through a playbook leaders can use to make metrics accountable, auditable, and repeatable. Before we dive in, a quick note on perspective. Imagine an implied guest, a senior data and AI executive who has led measurement programs at scale for commerce and subscription businesses. I'll reference that point of view throughout, strategy to execution, and the trade-offs that matter when you own outcomes as an executive. Think of metric engineering as product engineering for metrics. It's not just math. It's an end-to-end discipline that starts with the business question and ends with a reliable experiment, attribution plan, and production measurement that the organization trusts. Let's define the problem plainly. The board asks for a 5% increase in customer lifetime value. The data science team builds churn models and improves AUC, but lifetime value doesn't budge. Where did the value go? Often, the missing step is a conscious metric engineering process that maps LTV to decisionable signals, specifies offline proxies, and designs experiments to validate causality. Step 1. Decompose the business KPI. Break LTV into subcomponents: acquisition, retention, monetization, and ask which decisions change these levers. For retention, is the decision personalization, targeted offers, or fraud prevention? You only optimize what you can action. The decomposition must produce a decision point that a model can influence directly. A practical technique we use: decision trees that bind actions to outcomes. For each action node, you define the minimal signal needed, the latency tolerance, and the acceptability of false positives versus false negatives. That gives you a decision-level objective you can engineer toward. Step 2. Select offline proxies with an explicit validation plan. Offline proxies are tempting: lift in predicted score, click-through rate, precision at K, but they must correlate with the live KPI. Run quick backtests, held-out validations, and causal checks. If your proxy diverges from live impact in a backtest, don't scale. A pattern we often recommend: layered proxies. Use a conservative binary proxy for launch decisions and a finer-grained continuous proxy for online tuning. For example, use a purchase-no-purchase proxy to validate initial treatment, then optimize expected spend per user as you scale. When you design proxies, always document failure modes. Ask, under what business conditions will this proxy break? Seasonality, promotional windows, or changes in user behavior can decouple offline signals from live value. A short note in the model card saves months of confusion later. Step 3. Align loss functions and reward signals to value. If your objective is revenue, a log loss on conversion probability may be insufficient. Consider value-aware losses or policy optimization, where misclassification costs are weighted by expected revenue impact. The cost of a false positive is not the same as the cost of a missed high-value customer. If you can't embed business value directly into the loss, make it explicit in your evaluation stage. Report expected business impact metrics alongside technical metrics, and require that product and finance stakeholders sign off on the evaluation criteria before deployment. Step 4 is measurement design: attribution, experiments, and SLAs. Decide whether you'll use A/B tests, quasi-experimental designs, or observational attribution. For many decisions, a randomized controlled trial is still the gold standard. Where randomization isn't possible, use holdout cohorts and layered diagnostics to triangulate causal effects. Measurement SLAs matter. Define data freshness, logging completeness, and acceptable latency for impact signals. If your commerce KPI requires 90-day revenue windows, but you only evaluate weekly proxies, you'll need an explicit plan for intermittent validation, including interim leading indicators and a final long window check.
Now the hard part, trade-offs and common traps. Goodhart's law is real. When you optimize a proxy, it ceases to be a good proxy. Examples include clickbait optimization that increases clicks but reduces retention, or a fraud detector that raises false positives and kills conversion. Anticipate gaming and design guardrails.
Guardrails mean explicit checks, preserve diversity of signal sources, hold out control populations, and maintain human review for edge cases. Also, create an incident playbook for metric regressions. A clear rollback path and communication plan keeps trust intact.
Let's talk organizational implications. Ownership needs to be clear. Business owners own the KPI. Data teams own the proxies and measurement plumbing. And product owns the deployment. Cross-functional sign-off is non-negotiable. Align incentives. Reward teams on validated business outcomes, not just internal scores.
Governance practices I've seen work: model and metric registries, standardized model cards, and measurement SLAs enforced through a lightweight committee that includes finance and product. Keep governance pragmatic. Avoid red tape that slows experiments, but demand traceability for decisions that scale.
From a prioritization standpoint, favor high uncertainty, high impact bets that you can validate quickly. Early experiments should reduce uncertainty on the key linkage between action and KPI. If you can't validate a causal path in a few iterations, deprioritize scaling until you can. Looking ahead, durable practices for measurement include standardizing instrumentation across products, centralizing attribution logic, and building a culture of metric ownership. As models scale across domains, keep your measurement primitives portable. Consistent event models, schemas, and experiment frameworks. Risks to watch. Complexity drift, where teams create bespoke proxies for every use case, and measurement debt, where logging gaps accumulate. Both erode trust. Your antidote is ongoing measurement hygiene, periodic audits, living documentation, and accountability for data quality.
A short list of tactical checks for leaders. Require a one-page metric engineering plan before funding. Insist on a simple experiment with a clear primary business metric, and mandate a post-launch measurement review. These steps keep the organization honest and aligned. Before we close, 2 actionable insights you can implement in the next 30 to 90 days. 1. Run a metric decomposition workshop for a top priority KPI and produce decision-level objectives. 2. Deploy a small randomized validation or holdout on the next model you plan to scale to confirm your offline proxy correlates with live impact.
Final reflection. Models are powerful, but without metric engineering, they're just models. The work of translating strategy into measurable decisions is what turns predictive power into commercial value. Make the measurement pipeline as important as the model pipeline. That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.